So we're going to look at the topic of conditional probability, which is effectively the probability that something happens based on given that we already know something else. So in this example here, we might want to know the probability that given that we pick someone that definitely likes chocolate, what is the probability that they also like vanilla? So we are effectively creating a temporary universe inside our universe. So in this example, we've got 100 people, and they've all said how they prefer their ice cream. And in the example I just said, if I'm saying that given that they like chocolate, our universe is narrowed down from 100 people down to the 30, 21, 14, and 2 people that like chocolate in different combinations with other ice creams. And so we just have to think about these a little bit when we're answering our questions. So the first question is saying, given that a randomly selected respondent likes vanilla, find the probability they also like chocolate. So we write this down like this. So it's the probability with a P. We want to know the probability that they like chocolate given, and what we use is a vertical line, given that they like vanilla. Well, this is equal to the intersection of chocolate and vanilla. So that's the overlap. So chocolate intersecting with vanilla. So you can think of that as the probability that they like chocolate and vanilla. Now you can hopefully see that this represents these people here, those 21 plus 14, those like chocolate and vanilla. And that is all divided by all the people that like vanilla, which again, hopefully you can see is all of these people. So that would be our 21 plus 14 divided by our 21 plus 14 plus 5 plus 16, which would equal 35 over, well, we know that's 35, plus 5 is 40 over 56. And as always, we don't need to simplify that probability. Cool. So the next one. Given that a randomly selected respondent likes chocolate, find the probability that they also like vanilla. So this is the other way around now. So this is saying that I want to know probability that they like vanilla given that they like chocolate. So we've actually done some of the work already because the intersection doesn't really matter about the order. So we can take that value, but this time it's going to be over the probability that they like chocolate. So we've got our 35 people up here over, well, how many people like chocolate? So that's 51 from the 30 and the 21, plus the 14. Let's just add these up then. So you've got 30 plus 21 plus 14 plus 2. And that makes 51, 65, 67. So two completely different probabilities there. And if you see, because the numerators are both 35, we can compare with the denominators. And if the numerators are the same, the bigger the denominator, the smaller or less likely the probability is. So far, A is actually a more likely event than B. Okay, final question in this section. So let's just scroll this down a little bit. We've got, given that a randomly selected respondent likes chocolate and vanilla, find the probability that they also like strawberry. Okay, so I'm going to do this with actual probabilities now. So the probability that they like strawberry, given that they like chocolate and vanilla. Okay, all right, so this is going to be the probability of the intersection of strawberry with the intersection of chocolate and vanilla. All right, so that's effectively the intersection of all three divided by the probability of the intersection of chocolate and vanilla. Now, just a little bit of advice when using this formula. I always sort of think about the given part as being on the outside here. It's the one on the right, and it ends up being the one at the bottom here in your formula. With more practice, you'll get used to seeing where they go. So in question B, you've got chocolate, chocolate, chocolate. In question A, you've got vanilla, vanilla, vanilla. It just takes practice. So going back to this. So the probability of getting that overlap. So let's have a look then. So we've got 100 people and 14 people are in that overlap of all three. So that would be 14 over 100 all over, and then this one is the intersection of chocolate and vanilla. So the intersection of chocolate and vanilla is 35 over 100. Now, the first two questions, I didn't do those over 100. I should have done, but you're going to see why this isn't going to matter. You don't have to take the whole universe here, because I'm doing a fraction divided by another fraction. As you should know, that is the same as doing the first fraction multiplied by the inverse of the other fraction. Now, you can see that those things cancel, and we are left with 14 over 35.